Hello and welcome to DDD 2021. I'm really pleased to be joined by Saamer Mansoor, who for the next 45 minutes or so is going to talk to you about controlling his Raspberry Pi hand sanitizer with a mobile app, which sounds really cool. Saamer, over to you.
Hey everyone, thank you so much for joining. I'm super excited to share what I learned. It's fantastic to be a part of all these awesome speakers out there. I'm so glad that what I am excited about, people seem to be excited about too. So if you have something exciting, definitely fill out these forms and apply to speak for the next year's conference. But today what we're going to do is we're going to talk about how I got my Raspberry Pi to spit out hand sanitizer using a mobile app. And so there's so many different moving parts, and if you have no experience with mobile app development, you have no experience with Raspberry Pis, no experience with electronics, this will still lead you to the end goal. Like, this is for absolute beginners, and I hope you enjoy what I am looking to share. And there's going to be a lot of cool stuff, so stick around. A little bit about me. Who am I? I was basically a nobody, not too smart, but in university, I met this guy called Omar. I love this guy, great friend still. He taught me a lot about Arduinos and installing custom operating systems on your phone. So if you had a Windows phone back then, he taught me how to install an Android on top of that. So it was pretty cool. I learned a ton. If your iPhone camera was messed up, you pay $5 on eBay, you get the camera, you install it yourself and start paying like all this money to get it fixed. So it was pretty cool stuff. And then when I graduated, I worked for a little bit, and then I did a coding bootcamp called EPICU, where I studied C#, and then using that, I did a fun final project that helped me get into a company called Exigo, where I started my Xamarin mobile development. Throughout university, I was really excited about robotics and all this really cool stuff. And so I really want to be able to control those robots that I built using a mobile app. And so it was a fantastic learning experience for me. And then I participated in a bunch of hackathons, some of which I won, or at least I placed in top 3. And so that really motivated me to learn super quick, on the fly. You have 48 hours, got to learn, and try to implement it immediately, looking for the quickest, fastest solution, and all these neat tips and tricks that you learn from other people, because I never went with the same people. I always made new teams so I can learn from each one. It was great experience, and I highly recommend hackathons. And then, there's obviously so many videos like this one out there. But there was a video by James Quick that really helped me. He's a fantastic guy, and he has some really good tutorials. And he helped me learn what I needed to in order to get to the end goal of being able to control these electronics with a mobile app. Currently, I live in between Windsor and Detroit, Windsor, Canada, or Detroit, United States. And I've been all over the place, lived in so many different cities, and so. It's been a fun experience so far. I work as a mobile app developer. I've done a ton of mobile apps with millions of downloads, and so different technologies too: React Native, Xamarin, Xamarin Native, Xamarin Forms, and then Swift UI. So it's a lot of it's been a really cool journey so far, and I'm really glad. So what was my inspiration for this specific demo or this specific project that I had? So obviously coronavirus hit, everyone had plans, and now everyone was stuck at home. Unfortunately, it didn't really cancel my bills, so I was like, okay, I guess I should continue just learning and figuring stuff out. And then so I used the time that I had to build something cool, build something new, kind of looked at the trend, and I was like, okay, this seems like it could be like something trendy. And I was just like curious myself. I was like, hey, I have all this knowledge. How can I actually apply it to build something cool? So the first part of this is what we're going to use is Xamarin, just because any technology can use, but cross-platform technology is definitely something that beginners could learn, because there's a lot more jobs in cross-platform development and also a lot more junior jobs, which is why it's so much more attractive than like a native developer job. And then, the top cross-platform tools are like Xamarin, React Native, and Flutter. Flutter by Google, React Native by Facebook, and Xamarin by Microsoft. Xamarin is definitely one of the older ones. And so, we're just doing Xamarin today. But, feel free to use whatever, like a lot of this stuff is going to be very similar. And so we're just like going through the basics of like what's hybrid app development versus what's cross-platform app development. So, so a lot of people use these terms interchangeably, and there's not too much consensus. There's no like unifying body. Like Microsoft can't just be like, oh yeah, this is what hybrid development is going to be called. This is how I'm going to define cross-platform development. So like, no one's going to care if they did that, and so like there is no specific definition. But there's native development, and then under native development, you can either develop it separately, and what that would mean is you code it in two different languages, like Swift for iOS or Java for Android, or you can use one language, and then there's different tools that convert the code that you write into the native code itself. And so you're not really losing anything, or you aren't losing as much. And for most, I would say like 99% of use cases, you don't really need to go full native. You can go native cross-platform. Hybrid, generally, you don't have access to all the APIs. For example, what that means, you do end up losing with native performance. You don't have access to the actual label. So what you see on the screen is not an actual slider that Apple made. It is it's pixels, or it could be like a web version, and so you don't get all the functionality that a label generally would have, or a search box would generally have. And that's what that does, is that kind of messes up with accessibility and different features like UI automation and things like that. So I personally always recommend to people to use whatever technology that works in their specific situation. So it's really a case by case. A lot of times, stuff like Ionic, which is hybrid development, or it's also called PWA, progressive web apps, can also work for that intended purpose. So it's really, what really satisfies your purpose. Like I said, I have done Swift development, and the purpose that I did Swift development was, the application required only functionality that was available on iPhones. So like an Android phone would be essentially useless. So it was like, it just makes sense to do an iOS app. And it was like for 3D scanning. So it was more advanced functionality. So you can't really use like an Ionic app for 3D scanning on your phone using the phone's capabilities. Like, yeah, you can use like third-party libraries, but then, you're not going to get that amazing performance that you get with the actual phone itself. So what is Xamarin? Xamarin, there's two main kinds of Xamarin development. One is Xamarin Forms, which is the most popular one right now. 90% of apps use that. And then there's Xamarin Native, which was the original, which is probably like around like 10 years now. It's like very, very old. And what Xamarin allowed you to do is use C# to build iOS and Android apps both. And that was a game changer, because otherwise people had to learn two very different like languages. And then, I mean, learning a language is not too difficult, but then, you know, there's the architecture for two different types of architecture, and, you know, two different ways of doing things. And it was very, very complicated. And so Xamarin was like a freaking game changer. But like, you have this shared C# backend, but the UI in C# was still very difficult to do, because iOS and Android are so freaking different. But then what they did, they were like, hey, you know what? Like, let's just simplify it for people. And so they made sure that people didn't really need to learn about iOS and learn about Android separately. You know, they just like made that easy for them. They don't need to learn about view controllers and fragments and activities. It's just pages. So it was pretty awesome. It still is really cool. Now, you know, like I said, for beginners, if you are just getting started, I recommend a Mac for any sort of mobile app development if you want to make an iOS app. And so you can just download, you know, Visual Studio for Mac. You can also do mobile app development with Visual Studio. Not too much support for Visual Studio Code, but it is possible. Let's say you download your Visual Studio for Mac. You go next, pass through everything. It's installed now. All you need to do to create your first app is you click the Visual Studio button. You say new project, select blank forms app, and then you put in the name, and then you see that plus sign over there. I mean, the play sign, you just tap that play button. That's it. So we're gonna do this really quick. I'm just gonna go here, new, and it's gonna take some time to actually build. So we're not going to wait for it to build, but I'm just gonna click that play button so you understand. So app, blank app, say next, and then just say developer, developer, developer. And you know, you don't need to change any of that, but then you say, okay, you want to build an iOS and an Android app, hit create, and bam, it just like does some loading. And it's essentially creating 3 different projects. One is the iOS project, which you don't need to change, the Android project, which again, you don't need to change. And then it creates the shared project with a shared code. A lot of this stuff is going away with the new MAUI, multi-app UI framework that Microsoft is coming up with next year, like mid next year. But you know, all this knowledge is still going to be applicable for that as well. It's almost like equally used over there as well. Let's see, iOS, so debug, default, and then I choose my. So yeah, now you can either build the app to the Android phone, or you can build it to an iOS phone, essentially. And over here, we have a list of phones that are connected, or just the simulator that Apple provides you. So I'm just going to select like iPhone 8, and I'm going to hit play. While it's building, I'm going to continue, but I'm just going to show you what exactly it's going to show. So the starting point of your app is the app.xaml.cs, or your app class, essentially. What it does is it just initiates another page. So it says, okay, you know, your main page is actually this other class called main page itself. Okay, and inside that main page, and that's all that the app.xaml does. So if you create another class called, you know, dashboard page, you'll just change it over here to say main page equals new dashboard page. Exactly. Then you go over here, you have your constructor. So you have, this is your class. You have the function that's named the same as the class. It's just over here, and it says initialize component. So where's this initialize component coming from? So what initialize component does is that it just goes in to this XAML file, and it just runs this code. So if you remove initialize component, it's not going to run this code. It's not going to show anything. And what they do, this is essentially called partial classes. So there are 2 classes that have the same name, but they're in different files. And so the reason they do that is that they want to separate the essentially the UI code from the business logic. So if you want to have a function, you put it inside your main page.xaml.cs. So if you look over here, it says welcome to Xamarin Forms. I'm just going to make a simple change. I'm going to say, welcome to developer. And then I hit save, and there's something called hot reload, where if you just hit save over here, it goes ahead and updates this over here as well. So if you have a 20-page app, and you're 20 pages deep, you probably don't want to be 20 pages deep, but let's say the business requirements require you to have an app that's 20 pages deep, and you want to make a change, instead of having to build it every time and then go log in and go 20 pages deep, you just go over here, type it in, and just hit save, and it will update the UI. So it's really great. And this is also a game changer. So Swift does not allow you to do this. And so what that allows you to do also, like, for example, you're like, let me see, I'm going to change this to font size 18, so it's a little bit bigger. And then the designer's like, no, actually, you kind of make that 19. And so you don't have to like keep iterating all the time. It's very, very smooth. So essentially, Xamarin's pretty awesome. So what are you looking at over here? So in Xamarin, all you have to remember is pages, layouts, and views. So pages, layouts, views, pages, layouts, views. So over here, you have your page in the outside is your page. So it says you see content page. So there's different types of page: content page, master detail page, navigation page, and all this stuff. But we're just going to worry about content page for now. So you can only have one page inside a page that you're seeing, but you can have multiple layouts inside a specific page. So you can have multiple stack layouts, multiple scroll views, multiple frames, different, stack layout that's horizontal, vertical, in order to build your UI. So over here, you see it says username, password, and a button to log in. You just say stack layout. You put in inside your layout. Remember what we have? We have views. So entry is a view, button is a view. So you have your entry view and you have your button view. See, 2 entries and 1 button. Okay. Similarly, over here, like I said, you have 1 page, and then you have a layout, and then inside your layout, you have a bunch of views. And then obviously, you can have a layout inside a layout as well. So you see this frame is a layout, but it's inside the stack layout. And then, you have a view inside that. So now if you, for example, want to add a button that says click, text is click, and then you just close. Oh, yeah. So you see it added a button at the bottom. But now if you wanted to do some sort of functionality, you add a clicked function, so you assign a function to the click event. So whenever someone clicks the button, essentially it should call this specific function called button underscore click. So where is this logic? Where does it live? You go over here, you see it automatically created this function over here. So, you can just say console.log for now, console.writeLine or debug.writeLine, whatever, however you want to say it, and then just say hello. So every time you press the button, it should read this console.writeLine. But right now, the way that they have it set up is that if you make any changes in your C#, you actually have to stop it and then start it again, and then it will make those changes. So, as soon as it builds, we'll see when you click, it actually will show that, console.writeLine. So it's super specific. I did not make any change. Sorry, super simple. I did not make any change. You click on the click button over here. You see it says hello over here. So you can make it do any sort of work. You can make it show pop up or whatever. But that's going into more advanced. You don't really need to worry about that stuff. It's just simple for you to know. So if you don't want to do stuff in XAML, this is not something that a lot of people know. They don't really advertise this, but I like to tell people because a lot of people are like, oh, I don't really want to use XAML. If you don't want to use XAML, like I said, you just have to remove this initialize component function, and then you can just put your UI in C# itself. And there's so many ways of doing this to make it look neater. Okay, connected electronics. So this part is for, essentially, again, beginners. Electronics are super fun to play with. A lot of people are like, hey, I don't know what to do. I don't know what to use. What's a microcontroller? What's a microprocessor? Like, I don't even know where to start. So, I'm going to go super basics. So microcontrollers are things like Arduino. Microprocessors are things like your computer or a Raspberry Pi. Microcontrollers are usually supposed to have one function, so they perform a specific one functionality. Microprocessors, obviously, you want to do like multiple things at the same time. Build apps, go on the internet, do this, do that. So that's like a simple definition, a simple difference between the two. Obviously, there's like a million more differences. And usually microprocessors have multiple microcontrollers inside it. Whereas microcontrollers usually very simple, a very specific functionality. You don't want to use have too much on it so that it doesn't take up too much battery. So you like simplify it for that purpose. And then you'd essentially allow it to run for 3 years on a specific battery. Microprocessors, usually they don't really do that. Basics of just electricity. So what's direct current versus alternating current? The current that you get from your in your homes is called alternating current. Usually it's at 110 volts or 220 volts, depending on where in the world you are. 330 volts or 400 volts, like 440 volts. That is all alternating current. And anything above 30 volts is usually considered dangerous. And so, you don't want to put your fingers inside like the plug outlet. But what we work with and what your phone works with, for example, you put in the adapter, it converts the alternating current to direct current at like 5 volts. So it's very, very safe to work with. So, when you're playing around with these electronics, feel free to like touch stuff, it's okay. And then the other thing to note is your ground. So there's a live wire and a ground wire. If you have ever looked at like, oh, I don't know which wire to cut. So usually there's a live wire and a ground wire, apart from other wires that you have. The ground wire is considered the negative wire in direct current, and it's usually the black cable. So when you're looking at stuff, you're like, hey, why is this red? Why is this black? The black is the negative side, and it's called the ground cable. Okay, and then your photon, so there's different types. We're going to initially play with microcontrollers. And so there's different types that are popular. There's obviously the Arduino. There's ESP32 that are super popular as well, ESP826. What I'm going to show you is specifically the photon particle. So the advantage of the photon particle is that what you can do is you can just essentially debug and put in code onto the photon particle from your browser. So you don't really need to connect it to your computer. It's as soon as you connect it to the internet, they have an app and it's simple to do it. You just go to this website and you just launch the code from the website. So you just click on this flash symbol and it puts the code onto your photon particle. And so, for example, if you connect it to, for example, cellular device, like they have different types of devices. So if it has cellular service and it is like in some far off wind farm, and you want to change the code a little bit, you don't want to drive all the way there and hook it up to your computer and make the code change. So essentially you'd use a device like the photon particle, which is always connected to the internet. And it's super simple to set up. So I recommend, if you're a starter, definitely check it out. It's only $20. So very, very affordable for people. LEDs. So LEDs, there's two sides to the LED. One you'll notice is a shorter end and the other one is longer end. The shorter end is the negative end. If it doesn't work, just flip it over and you'll be able to see it working. I already talked about like coding through the browser, and I'll show you what that interface looks like. And then the code that you're using over here, the stuff that you see over here, is C++. So it might seem like it's super complicated, but if you look at it, it's just like any other language that you know. If you know JavaScript, it looks just like JavaScript, sort of. But what you should note is that there's two main functions. There's a setup function and there's a loop function. The setup function is only called once in the entire lifetime of the device. So as soon as you turn it on, it runs that setup function, and it doesn't run it ever again unless you like call it somewhere else. But the loop function is run like it's run multiple times in a second. But if you leave a delay over there, it'll just like pause, so it's not going to run it, because it's waiting over there. Otherwise, it runs like multiple times in a second. As soon as it ends, it comes back over here and it runs it again. So with the particle photon, it also allows us to use stuff like particle function, particle variables, particle events, and these are things that we're going to be able to use in order to make our app work. So how to get started? Just download the particle app, buy it, obviously, download the app, connect it to Wi-Fi, and then you need to do like this particle token create line, and then there's all these setup functions, and you can watch this video and like go through all of this stuff in order to figure out like all of this, what's going on over here. But you're essentially installing it so that you can run it on your terminal. I'm going to show you what it kind of looks like. So build particle.io. Yeah, so this is that IDE, or the online IDE, where you essentially are able to put your code. So for example, we have this code over here. You just say, you put it over here, and then on the left, you click on devices, you select which device you want to put the code on. So let's say the Raspberry Pi is selected, and then you just press the flash button and it will install or flash all the code onto the Raspberry Pi. Yeah, so moving forward, let's see. Okay, so this over here is our basic setup of a very simple, setup which just blinks the light. And I have a lot of this code on GitHub, and I can share that with you as well. I think I already shared one of the links, but this is your particle photon. It's very small, very tiny. It's probably the size of a small coin. Over here, you'll see that there's a GND button. GND pin. Okay, so and that is one that we're going to work with. And then over here, you see there's a D6 and there's a 3 volt over there. But this multicolor thing is called a resistor, and this is your LED. So the resistor is needed in order to not let the LED blow up. So remember I told you that the voltage is like 5 volts. 5 volts does nothing to us, but to an LED that's little, it'll actually blow it up. So you want to use a resistor to reduce the voltage that it receives, or the load that it receives, essentially, not really the voltage. But you drop the voltage, the load, in order for the bulb to not blow up. So it looks like there's a lot of wires. Like, this is obviously your microcontroller. This is just for power. So it looks like a lot of wires, pretty complicated, but let's simplify it. So remember we said that your ground is your black cable and it's your negative. So in direct current, your current flows from your negative to the positive. So it goes over here because it's a breadboard that this is sitting on. So it flows horizontally here, and you take this wire, move it to this negative, move all the way down because it's a breadboard. So this is vertical and this is horizontal. Okay, the current flows horizontally here and vertically on the edges. It goes all the way down, goes through the resistor to one of the pins of the LED, goes all the way here, and then it takes it to the D6 or D7, any of these direct current pins. So then what you can do with your code is you can just say, hey, I want the current to be high or low. So if it's low, that means there's 0 current passing through. If it's high, that means there's 5 volts passing through, and it's usually like binary, so 0 or 1 for digital pins. For analog pins, these A pins, that's where you can kind of get the different values. So over here, what you can do with the photon particle is that if you put in the code properly, over here, let me share. So if you set the code here, blink an LED. So I set this up over here, and I go to any sort of website. So I can create that website myself, or I can just go to CodePen, which some of you might know already, and just put in the HTML code on the side. It asks you for the access token that you create using your particle token create in your terminal, and then this is your device ID. So I took the device ID from here, tapped on this, and this essentially is your device ID. So I just copy that, put that in here, and it says, turn the LED on or turn the LED off. And I just select something, I say do it. Okay. And when your device is connected, it essentially will, light it up. And, you say which digital pin that you want to set it up towards. So there's so many different use cases of something as simple as this. What you can do also is, because you're essentially making a post call, you can use that same thing to do it from any device. It doesn't have to be from a mobile app. And so you can, this is just an example of it happening from a mobile app. Let me set it up here. File open. Documents, GitHub. Okay, here. Yeah, so essentially, again, you create a new project, you do the same thing, set it up, change your simulator to whichever you want, iOS device or Android, hit play. But, you can just like click a button, it makes that post call, and, you're good to go. So the advantage of this, like, how do you see it in the grand scheme of things? Like, okay, this is cool, but like, what can I really do with it? So there's this tool called If This Then That, and it's free to use. You can create an account, and I have an account with them too. And you just say new applet, or so it says if something happens, then do something else. So I'm saying, okay, if there is a variable that changes on the particle device, so if the LED light is on, then do something else, like send an SMS, send an email, send a phone call. Here, let me go here. If this, then that. Yeah, so I have like different types of things set up. One of them is my Philips Hue bulb, so if it's on, then my Philips Hue bulb turns red. Sorry, turns blue. If it is off, my Philips Hue bulb turns red. See that? Color when red, off. Color blue when available. So I can tap on it, and it shows me, the activity, and it says that it's connected. I can check now. You can also create a new one. So it says you're using 2 of 5 because I have a free account, so I can create 5 applets. So I say, okay, if something happens, so I can set the trigger to be anything, but I'm just going to set the trigger to be my particle device. So if my particle device, let's say the temperature is less than a certain value, so the digital value on the different device, so I have 2 devices set up, is greater than, let's say, 40 Celsius. So if it's very hot, then turn on the AC. Okay. So I know you already have like a thermostat in your house, but if you wanted to create a custom thermostat, then do something else. So then, you can hook it up to an air table. You can hook it up to like all of these like hundreds of different things that you can actually like set off essentially with this like tiny little device that you can create yourself. So you don't need to purchase like a smart home. You can create your smart home yourself. Like email someone, Evernote. So how have I used this in the past? So I used to live in a basement in Toronto. I know it's like, let me see, how am I doing on time?
You've got about 15 minutes left.
Okay, sweet. Okay. So I used to live in a basement in Toronto. Rent is super expensive in Toronto. Obviously, I could only afford a basement. And it was extremely cold in the basement because I didn't really have a temperature controller. The landlord who lived upstairs was the one who controlled the temperature. And I used to tell her, hey, it's cold. It's cold. I don't know what to like. And she'd be like, oh, yeah, yeah, let's set it up a little bit. And so she used to change the temperature a bit. But it was hard for me to like explain how cold it was. And I was too lazy to go to the store to buy a thermometer. So what I did, I just hooked up a sensor. So this over here is a sensor. You see these 3 wires coming from the sensor. And what that sensor does is it measures the temperature and humidity of the surroundings, essentially. And so I used if this and that to get that temperature and send it over to a Google Sheet. And this is all free. And then with a Google Sheet, what I did is I just like every hour, or was it every half an hour, I created a graph to show like how cold it was. And it was around like 16 Celsius or so. And so, which is below like the legal limit. And so like they immediately were like, oh my God, they sent me a heater. And then they like started some work to like make sure it's not cold and all that stuff. So it was, pretty useful, I can say, on a small scale. But then, there's other stuff that I've also done with it, on bigger scales for different companies. So yeah. Now, how can you use Raspberry Pis instead of like this? It seems like the particle photon, is proprietary, and so like, how am I going to be able to use a Raspberry Pi in order to do all of this stuff? The good thing is that they have stuff set up so that if you have a Raspberry Pi, you can do exactly the same stuff with your Raspberry Pi using their systems for free. So it's awesome. So let's say you bought a Raspberry Pi, you have it lying at home. You most likely have one, more likely than having a particle photon, you probably have a Raspberry Pi lying at home. So what do you do with this Raspberry Pi? You just need a Raspberry Pi and you need an SD card. And obviously you need to be able to power it up. So if you have those two set up, the first thing you need to do is you need to install a Raspberry Pi operating system on it. So you can go to, you see over there, it says raspberrypi.com/software. And then you download this like imaging software. And then you put the image of your Raspberry Pi OS onto the SD card. It's a micro SD card. And then, you just write it on. Once you write it on, you put it inside your, it probably take like an hour, but once you're done, you just put it in your Raspberry Pi directly. The thing with remember how we said that it's a microprocessor? So, you can do multiple things. The other thing with a Raspberry Pi, with a lot of people use over a microcontroller, is that you can also code it with Python. But, obviously it takes a lot more battery, and a lot of times, like, the little devices, they are very efficient with their battery consumption. So Raspberry Pi, if you're starting it from scratch, once you're done installing your Raspbian, you can go through these instructions by yourself. But, just make sure you connect to the internet, open the terminal, and then you have to install the particle CLI, or the particle library. Use this, and then, log in from the terminal, and then just say particle agent setup, and then it'll basically set it up for you. And then just make sure that when you're in, a lot of people mess this step up, just make sure that you select your Raspberry Pi to flash. So, instead of your photon, you just select this and make sure to get your device ID from there. And then, get the token using the CLI from particle token create. So what do we need to change here? You learned the basics of electronics, and how can we apply that to a Raspberry Pi? It looks a lot more complicated. So just whenever you have these electronics, look for something called a pinout diagram or electric circuit diagram. And this one, Particle created one for the Raspberry Pi where essentially it shows you which pin goes where. So the first pin on the top left is number 1. And if you see over here, you remember how we had the ground, we had 3.3 volts, and then we had D1. So we care about D1 and we care about ground. And we probably also care about, I think it was 3.3 volts. So it's, yeah. So you connect those over there, and instead of, you can just remove your particle photon from the breadboard, and you can just hook up the wires from there to your Raspberry Pi. Very simple. 3 different cables. That's it. One, it's like there's different types of cables, but this one specifically is like female to male cable. So 3 different of those, and you just hook it up onto your breadboard, and that's it. Just deploy the same code, and you can perform the same functionality with your Raspberry Pi. Super awesome. So how do we apply this in order to make an actual device, like something that's running a pump, and what are the different things that we need in order to create an actual device? So what we have over here is a Raspberry Pi. This is the stuff that you're familiar with, but what is the rest of this? So this over here is obviously a breadboard, and this blue thing is something called a relay. So there's 1, 2, 3, 4, 5, 6, 7, 8 relays on this. A relay is a switch. You know how there's a light switch, but instead of manually changing it, you can change it by sending in some current. So the 1s and 0s, you're basically sending a 1, and it will turn the switch on, or 5 volts. And you turn the Boolean on or to 1, and it sends in 5 volts of current. And so the switch knows to turn it on. And so you'll hear it click. It will click. And so it'll let the current pass through to the pump. This over here is a pump. There's different types of pumps. This is a peristaltic pump. You can use any one. But the thing with the peristaltic pump is that it does not, it has a lower flow rate. So, you're not flooding everything. And also, it does not contaminate whatever's inside it because the pipe just runs continuously. And so you can use like a food grade pipe that's very safe to use. And so it's not going to contaminate the food or like oil or whatever drink you might have. So pretty safe to use. It requires about 6 to 12 volts. So 6 volts, it'll be very slow. 12 volts, it'll flow normally. You generally don't want to control your flow rate by controlling your voltage so much. I would just turn it on and turn it off using your relay. And then over here, what you have over here is something called your power supply. So unlike your Raspberry Pi, which requires 5 volts of current, the pump requires, like I said, 12 volts. So you can use a power supply to convert your AC current from your home into DC current. So something like this. It converts from, in my case, it was 110 volts to 12 volts of current. So you go like that, plug it in, and then move one cable through the relay, move the other cable directly to the pump, and then get the other cable off the pump from the relay. And it just basically sucks out and I'm going to show this to you in the video right after, but it just sucks out the sanitizer from one bottle, and it just spits it out into your hand. And then you just enclose everything into a nice looking box and make it look like it's super complicated and difficult to make. But essentially, if you notice, it is so simple to make. You just have like these few components. You have 1, 2, 3, and 4 components, but like it's difficult for other people because you're smart, you're able to understand, you're able to follow, you're able to make it. But for other people, they have no clue to as to where even to start. So and this yellow thing at the bottom is just, to elevate the pump up. There's no other purpose. Obviously, be careful when you're handling something like this, the power supply, because 110 volts, remember, is very high and it can be dangerous for sure. So, and I have this code in GitHub. If you just go to GitHub, auto sanitize, Saamer. Yeah, so I have like multiple versions of this code. Let me see. Yeah, but if you just go, over here and just search auto sanitize, sanitize. Maybe I changed it. Yeah, but you go over here, you can get the C# code needed, but this essentially is your code. So you go over here, you set up everything in your main page.xaml.cs. So it says, make your life simple. There's a click button. So remember the button that we talked about initially in the first part of our presentation. So when you click it, it runs this function called sanitize me. You go over here and you can look for this button. So what does it say? It says sanitizer on. So what it does is it runs this function, and then for after 0.33 seconds, after a third of a second, it runs sanitizer off. Okay, and so in the video that I'm playing, and I can share the link to the video as well, you'll be able to hear the click sound go on, and then it goes off in third of a second. What is inside the sanitizer on function? It just basically passes in the on text into a function that takes the access token and the device ID, just like that browser, and it has the particle function name. So the particle function name we get from here, from build.particle.io. Let's see, code on sanitizer. It's a very, very simple code. Look at that. It's like 10 lines of code, probably. The rest is just comments. So there's the LED function that whenever you call it from externally, it calls this LED toggle function. And then it passes in whatever on or off text that you wanted to pass in here. So if it's on, it basically, writes one is high, the other is low. Or one is, it writes it as high, or if it's off, it just, turns it off. Essentially, it closes that switch. And then, basically it passes in that value as a post API call, and then you get a result that you can display any way that you want. But a simple post async call, you can use any language that you know in order to build something like this. Going back over here, and so let me show you the video. Let's see. 3 tabs. Here. Yeah. It was just working. Give me a second. Yeah, there we go. So you see over here, I have the same exact app that I showed you guys over here. I just built it onto my my device instead. So as soon as I click on it, it immediately spits out that sanitizer, and then it's turned off the switch in a third of a second. I'm able to rub it. I put it all inside a box, and there's 2 cables, one that powers up the power supply, the other one that powers up the Raspberry Pi. Okay, so I'm going to play it again uninterrupted. So you can kind of, like I said, you can make it look really nice. I just put the pipe out. So I'm going to play it again to sanitize me. Rubs it. I get the sanitizer, I rub it, and there we go. So that's, looks really complicated, but it is super simple to build and to work with. Yep, that's basically all I have.
All right, well, thank you for that. I'd certainly found that interesting. What the viewers on YouTube and elsewhere may not know is there is a DDD Discord server. So by all means, go and join in the chat and the conversation on there. Thank you, Saamer, for your time and such a great session. Thank you, everybody else, for watching, and hopefully we'll see you all at the next DDD.
Yeah, thank you so much. I really appreciate the opportunity, and feel free to reach out to me. Like I said, there's my GitHub. You can find some of the code over there. Email me, message me on Twitter, LinkedIn. Feel free to tell me what you're working on, and reach out for help for anything. Thank you so much for the time.